record on this computer. So welcome to our CCNA 3 class. Appreciate everybody giving me a week to go up to Canada. It was quite cold. We had temperatures 2 days in the -12 for a high. And so, yeah, those 2 days we didn't hike. We actually went hiking on a day when it was -9 and got to a point to where the snow was over knee deep. It was about almost, honestly, around waist deep in one area of the trail we were on. We were trying to get to this one special, these old bunkers, and we were got to what was really an avalanche field. And I was like, nope, we're not going any further. We're stopping right here. But it was a really good time. We had a lot of fun. So we appreciate y'all dealing with me during that. I hadn't got a whole lot graded, so be aware. I know I need to grade some stuff. I want to open up and ask if there are any questions about OSPF and OSPF single area. Any questions about those labs or any of the items that you have done in those particular sections?
Not from me.
Okay, any issues with the labs? Any issues with OSPF single area? Okay, yeah, it's real simple. Actually, like I said, they have dumbed down the CCNA a great deal. I will tell you, I have not heard anything at all about a new version of the CCNA. But I will also say this, it's been 3 years since a new version came out. Cisco also just released these new entry-level certifications, the CCST cybersecurity and CCST networking, which are kind of like the new CCENS. So again, I have absolutely no indication from anybody above me at Cisco that a new CCNA is coming. But if I was betting money, I'd put about a 75% chance there's a new one going to be released this summer. That would be my guess. And I think what they'll probably do is make it a little bit harder and map the CCST networking to CCNA 1 and 2, and then CCNA 3. This class, as you've noticed, there's not a lot of content in this class. Let's be quite honest. CCNA, this third module we're looking at today, we can literally go through in about 5 minutes because it's all Security Plus stuff. It really is very little new information for someone like you, or even one of your students who's taking CCNA 3. If they're like ours, they're typically a second-year student or at least second semester student. And so they probably already had Security Plus or a basic security class. So module 3 in this ENSA is not really going to challenge them very much. So again, I don't have a clue if there's something new coming out or not. If you were in the IPD week last week, started professional development week, someone asked during one of the technical overviews if there was a new CCNA coming. They didn't say a thing about it, but they were in contact with, I think there's one coming. I don't think it's coming anytime super soon. As far as I don't think it'll roll out next week, but I do think probably at Cisco Live, there'll be a revamp of Cisco's entire certification program, which I'm gonna be honest with you, it needs it. It's bad right now. It's just not in a good place. So I'm hoping they will. I actually like these two new cybersecurity, these two new certifications. If you're here tomorrow during our ASC ITC meeting, we actually have an hour and 15-minute session that Michael's going to go over the two new certifications. I'm going to ask him to record those in Zoom, so we'll have those to give to you later. If you're not going to be here tomorrow, I'm hoping I sent out that Zoom link. If we have enough bandwidth in the area that we're at tomorrow, I will be streaming everything live tomorrow from our meeting and also trying to record it. Just be aware it's going to be 4 hours worth of recording. So it's going to be a pretty big recording to try to put. I'm going to put it up in the cloud. I won't be putting it on a local machine and putting it on YouTube. It'll probably be directly from Zoom as a cloud link. But just kind of throwing that out there as an intro to kind of give you an idea of what could be going on as we move forward. Now, folks, I want to go ahead and share my screen here. Can everybody see can you see the module 3 here?
Yes.
Okay, I'm not going to spend a lot of time on this because let's be honest, as we look through this particular section, it is very easy to see that this is a general overview of security. What are assets, vulnerabilities? This has been pulled out of other courses. It is out of some cyber ops. Some of it is out of other items, but you can see it's pretty simple. Some of it's directly out of the Intro to Cybersecurity and Cybersecurity Essentials course. We've seen what is white hat versus gray hat. the evolution of hackers, cyber criminals, all of this. So if there's any questions on this, I'll gladly answer them, but I'm just not going to spend much time on it because it's something I believe you can read and be pretty familiar with. I will mention one thing here. I do want to talk a little bit about TCP and UDP vulnerabilities, because we all know about the three-way handshake. We know about SYN, SYNAC, and ACK. How many of you have heard of SYN floods before? Raise your hand or just say yes if you have SYN floods. So in other words, you send a large number of spoofed SYNs. The machines then send SYNACs, and they end up with a lot of what are called half-open connections because they're waiting for an ACK from a machine that doesn't exist. We mitigate SYN floods today with our firewalls. The firewalls actually have a way of sending information to close those half-open connections, but we can't turn off the three-way handshake. So sometimes there are protocol. Have you ever heard of what's called TCP vulnerabilities? And tell me if you can see my notepad when I bring it up. You may not be able to because I'm just sharing one thing here. Can you see the notepad? Should have just come up for you. Can you see it, bud?
I don't see a notepad.
Okay, let me stop my share and share it a different way. I have to share the whole screen. I was just sharing let me share the screen. Oh, you should see notepad now.
Okay.
Okay. If you ever heard of 10 TCP vulnerabilities, there are technology vulnerabilities. There are controls, and then policies. So this, when you look at SYN floods, you look at things like that. These are technology problems or technology issues in security, because we don't have the ability, actually not control, it's configuration, sorry, configuration. So you mess up a config, default configs, default passwords, those types of things. Policies are bad policies or lack of policy. Lack of policy is a real big one. Okay, so sometimes you'll see TCP vulnerabilities or TCP types of vulnerabilities. Well, one of those is actually a technology. Same thing with UDP. UDP has some vulnerabilities because it doesn't do a three-way handshake. But at the same time, we can't really turn off some of these things. And they show you here this SYN flood. So three-way, they spoof IP addresses, send a whole bunch of SYN to the web server. The web server sends SYNACs, and then it is waiting for an ACK to close that half-open connection. If you fill up the half-open pool, then the machine can't respond to any more requests. Again, we mitigate this with a router in the middle, and also some operating systems have the ability now to actually realize a SYN flood's taking place. UDP, little bitty header. That's why UDP is so much faster. UDP can flood, but it's, again, not as, it's one of these things where with UDP, firewalls can see that happening. We had an instance on my wife's business where we were getting flooded with basically SMTP requests, and it was a flood that was from Korea. And so I worked with the ISP, and we just turned, her business is a local nonprofit. I just turned off all IP addresses that originated in Korea coming into her business. Now, if I was Amazon, I couldn't do that, but that was one of the things I could do to actually take care of that. Now, we've talked about ARP vulnerabilities. We know about MAC address flooding. We know about MAC address spoofing. Remember that inside of a switch is a table of MAC addresses called the content addressable memory cache, and we can poison that cache and thereby make machines believe we are the default gateway, or vice versa. We also can flood. If you flood a switch, and this is a fun thing to do, if you've got an old 2960, or if you've got 2960 or any switch that's a lower level switch, get a program that can do a MAC address flood it, and you will see that it suddenly becomes a big old honking hub. It's all it is. It'll sit there, and everything that goes in one port will go out to every single other port. And so once you flood that table with MAC addresses that have been spoofed, it will allow it to act just like a hub. This is a big one that is becoming more of an issue, and that is MAC address, DNS tunneling. DNS tunneling, now one of the big things is, especially IPv6 DNS tunneling, we can't turn off DNS, that's a definite. But what they actually do is they take DNS and they embed commands into it and use that for malware and for other items. The other thing they'll sometimes do is, and we've done this as an example inside of class, you can actually use a ping request, and in that data that's just like a pad, you can actually put in data and put in messages in it, which is kind of fun to do in class. But DNS tunneling is a big one. Many of our more modern, like Palo Alto and even Cisco's ASAs and their modern security devices can realize strange or inappropriate DNS action or traffic, and will actually stop it. But that's a big one. We talked a little bit about normal DHCP operation, and we have talked already about IP snooping. So creating trusted and untrusted ports. That was part of the switching routing wireless essentials class. You remember what IP snooping does? What's the purpose in IP snooping?
I think what it does is this has to do with about like a rogue DHCP.
Yep. Basically, by using DHCP snooping along with, and you have to use also ARP, looking at the ARP request. But what it does is it basically says certain ports are trusted to provide DHCP responses. And so when this DHCP discover goes out, it goes out and gets flooded to every single port, but only the DHCP server that is on a trusted port is allowed to respond. The rogue DHCP server, if you're not using DHCP snooping, the rogue DHCP server could respond, but with DHCP snooping, it's not allowed. So in other words, when the request comes in, snooping says, nope, I'm sorry, this is not allowed. You're not allowed to come in from this rogue agent because we only trust the port the DHCP server is on. And so we set that up, and it's a way of stopping rogue DHCP servers. Okay. You got the lab on DNS traffic. That's one that's not, you don't actually use NetLabs for it. And so you can do that. You've all heard of CIA, confidentiality, integrity, and availability. We provide confidentiality by using encryption. We provide integrity by hashing. We provide availability by redundancy measures, like backup. Folks, I got to tell you a very embarrassing story on myself. I have been dealing with an issue to where whenever I would play a game or use my software on my machine that would be slicing software to slice a big file to go to my 3D printer or anything that would stress the graphics card, I would be getting an alarm. And I mean, it's been driving me crazy. So I put new fans in thinking it was heat, but I was monitoring heat, everything was fine. I was monitoring voltage, everything looked fine. I had one power cable going to the GPU, and it had two connectors on it, a 6-pin and an 8-pin. Well, I split that and put two cables to it, thinking maybe it was that. Still had the alarm. I finally got so frustrated, I said, all right, I'm gonna sit down on the floor here and listen. Sat on the floor, which for me is hard because I can barely get up and down off the floor. I sat down on the floor, started a game that would stress the GPU, heard the alarm and looked, and lo and behold, it was actually my UPS alarming, not my PC. The UPS was sitting right behind the PC. All this time I thought it was the PC. It was actually the UPS behind it. So I'm telling on myself, but the reason I mention that is because the reason I had that UPC is because I wanted availability. But come to find out, if you have an 800-watt power supply and a 650-volt UPC, it will actually alarm when it starts pulling too much power. And the nuts thing is, it never did it until I started something that actually was graphics intensive and the card started pulling power. So I'm telling myself I'm an idiot. But the good news is now you know that maybe you won't have the same problem. Crazy enough, I actually was reading online and someone else had the exact same issue, and that was what was happening. But it was crazy. It would only happen when it was stressing the system. So maybe that'll help you and you won't have to worry about wanting to have the same problem that I had. ESA, WSA, these are mentioned if you ever had the cyber ops class, the email security appliance, which is basically Cisco's spam and malware filter that can be an appliance or it can be like a hosted service now. And then the web security appliance, same thing, can be an appliance or it can be a hosted VM. But basically it looks at either all email traffic coming in and out of your system or all web traffic coming in and out. And last but not least, a little section on cryptography, which again, I'm not going to spend much time on, but just, you need to know the difference between shared key and PKI. Difference between hashing and encryption. Remember, encryption hides the data. Hashing ensures integrity or data integrity. So asymmetric versus symmetric encryption. Symmetric encryption is using the same key on both sides. Asymmetric is using a public-private key pair. So typically two different keys. And then Diffie-Hellman we'll learn a little bit more about as we get down later in a section. Actually, if you're in my network security class or going to do my network security class starting tomorrow, we'll talk about Diffie-Hellman as it relates to VPN connections. But Diffie-Hellman is a way to actually generate a shared key, but doing it without ever actually passing that key across the link between two devices. So it ends up being an agreed on color, and it looks complicated, and it is somewhat complicated, but it works out where you end up with a shared set of keys that are the same between two devices without ever sending that shared key across between those two devices. Okay. So that's module 3. Let's talk about ACLs though. Now this is something that is very important. Access control lists show up everywhere, okay? And one of the things I teach my students is I teach my students that ACLs or access control lists, okay, are a series of permit and deny statements. All right. They are applied sequentially. Top down. In other words, you work your way down through them. They end in an implicit deny all. Okay. Now, the other thing I like to teach is this. You can have one ACL per protocol, per port, per direction. And remember, directions are in and out. I call that the 3 Ps, per protocol, per port, per direction. And this is the basis for access control lists. Now, what can they be used for? Everything. They can be used for security. They can be used for filtering traffic. They can be used for filtering it. They're used for filtering access to your VTY line. We've learned about that, doing access control list, or well, we'll learn about that. Access control list to control who can get into your VTY lines. It can be used to filter even routes going in and out of OSPF. You can use route filters that map to ACLs, that then map to route maps. It can be, there's so many different uses for access control lists. So it's not just for security. There are others. Now, we typically think of them in terms of security or traffic control or flow control, but they have so many more uses inside of the iOS. We do typically with them using either standard or extended access control list. We filter based upon protocol and IP address. So usually it's layer 3 and layer 4 filtering for the access control list that we use. So remember this, anytime you need to determine the direction of an ACL, consider it from the person in the router itself. So imagine there's a little gnome sitting inside this router, ACL direction is from the viewpoint of that little gnome sitting in the router. So inbound is coming into any port on that particular router. Outbound is going out. So even though the inbound ACL is pointing from left to right, there could be an outbound ACL going from right to left on that same interface. So every port can have an inbound and an outbound ACL applied to it. Does that make sense? That is where people get confused all the time about ACLs, is where am I sitting? Okay. Each one of the access control entries, or ACEs, are one of those permit and deny statements. So series of permit and deny statements, which are sometimes called ACEs, or access control entries. Now, I like to discuss wildcard masking here. We've already talked about it in OSPF, but it's the exact same thing in ACLs. But here's the thing, ACLs must have wildcard masking. I remember I taught you a little trick. Last class, I mentioned that you can actually do ACLs, or excuse me, you can actually do OSPF and use the subnet mask, and it will automatically convert it to an ACL or to a wildcard mask. ACLs won't do that. You must use the wildcard mask. All right. Now, if you do all zeros, that means it must match exactly. If you do, this is matching the first 3 octets, ignoring the last 6 bits. So a wildcard mask, anywhere there is a 0 is significant. Anywhere there is a 1 is insignificant. In other words, if there's a 0, those are bits you should pay attention to. If it's a 1, you ignore it. The other thing that's important is it's kind of hard to understand a wildcard mask without having the preceding IP address with it, because it has to really be compared to. So I do 192.168.12.0, and I use a mask at 0.0.0.255. That tells you that that ACE, that entry, would apply to any address that has 192.168, it should be an 8, 168 in the first 3 octets. It does not care what's in the 4th octet whatsoever. So if I give you an ACL or a wildcard mask at 0.0.0.3, okay, and nothing else, all you can tell me is that the important bits are all but the last 3 bits. You can't really use that in an ACL. But as soon as you give this to 10.0.0.0, then you know that applies to the subnet 0 to 1 through 3, basically, or 0 through 3. Okay, so we use them and we compare it to the preceding. So if you need to match a host, a single host, you use quad zeros. So here's an example: is you want the access control entry to apply to 1.1 only, use quad zeros. That means every single bit must match exactly for that access control entry to. So if I did a permit 192.168.12.1 0.0.0.0, that means permit only that one host, nothing else. What if I wanted to permit all hosts in that particular network? What would I put? Permit 192.168.12.0. Then what would I put in?
0.0.0.255.
Exactly, 255.
You know what I found easier to do, Kelly?
What's that?
Because it gets really complicated when you try to do those wild masks when you actually got like a 255.192.
Yep.
What I do is I do the normal 255 all the way across and then subtract it from that subnet mask.
And that's the easiest way to do it. Just subtract it from your standard mask. So for instance, a great example, let's imagine I had 192.168.12.32, and I wanted to match, and my mask is 255.255.255. Let me do my math here. 224.
Yeah.
So let's say I wanted to match that. Just subtract it from
255.
Yep. So it'd be 0.0.0.31.
I mean 31 because it's gonna be 32, so you subtract that one, so yeah, it'd be 31.
Exactly. And so that'd be wildcard mask that would match this subnet right here. Okay, that's exactly how I do it too. Okay, so here's an example. Oh yeah, here's an example of matching the entire subnet, the /24 network, what I just showed you here. So, and even if you do use the 192.168.1.1, if you use this mask, it doesn't matter. It ignores everything in the fourth octet. So no matter what you put here. Now I would have put 1.0 because that's the correct way to write this. This access list right here is correct. But if you had accidentally put 1.1, as long as you use that 255 there, it's going to ignore whatever's in the fourth octet anyway. Here's an example of the subnet 16.0, and it's a they're actually trying to permit all hosts from the 16.0 to the 16.31 network, and you just you use the subnet mask, subtract it, boom, there's your wildcard mask. Now let me ask you something. Let me ask you a crazy question. How do I permit all of the odd addresses in a network, or all of the even addresses?
Man, I forgot.
Here's what you do. You'd use 000254, and then if this number is even, it will match all even addresses. If this number is odd, it will match all odd addresses. Because remember, 254, convert that to ones, is, back up, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I got one extra. 7, 8. So in other words, this is saying ignore all of the first 7 bits, but whatever the last bit is. So if it's a 1 here, that means it's an odd number. If this is an even number, so remember, access control list entries, it's always the IP address as compared to the wildcard mask. And this would match all even host. This would match all odd hosts. Does that make sense? Yeah. Okay. We don't, and that's not something we're going to use very much, but it's just something I throw out there so you'll know. We're going to use much more stuff like this right here, 255, or like this, 31, which would match the subnet 0 to 31. Okay. So be aware, I just teach that because occasionally you see that come up. All right. This is the best way to do it. Just subtract it from 255, 255, 255, 255. And that will give you your wildcard mask. So whatever you happen to have there, it's what you get. Now, we can make things a little easier on ourselves. So if we were going to use this statement right here, which means match that one host, we can write that as permit host 192.168.12.1. And that just means that replaces quad 0. All right. We also can use any for 255, 255, 255, 255, which means anybody. So this statement right here means this says permit any host that is 192.168.10.10, and then also permit any other host. So, and that's actually a very dumb access control list, because this basically says permit this one host 10.10 and then permit everybody else. And then what's at the very end of it? We don't see it, deny all, right? So there's a deny all at the very end. So that's a very dumb example, but it's an example, okay? We could rewrite that though as host 192.168.10.10 and any, which replaces quad 0, quad 255. Here's their guidelines for creation. 1 outbound IP for 1 inbound. So 1 ACL per protocol, per port, per direction. So if you're running IPv4 and IPv6, you could have up to 4 ACLs on a single interface, 2 inbound, 2 outbound. So best practices, base it on your security policy. And that's just a given. So, and when you start writing ACLs, you need to think about the logic. One of the things I can tell you is this: we typically do our denies first and then our permits. You also want to deny since each one of the ACEs are done in sequence, sequentially. So it goes through and says, does it match this one? No. Go to the next one, go to the next one. We try to put the ones that are matched the most at the top, but they need to be deny statements that are matched the most. Okay. Write out what you want the ACL to do. So in other words, any of you used pseudocode before? You know what pseudocode is?
Yeah.
Okay. So you just write out kind of a pseudocode. So we know we need this. We need to deny hosts on the 10.0.0.0/8 network. Okay. We need to allow access to DNS at 8.8.8.8. And we need to allow all other. So we just kind of write a pseudocode. And then we can sit down and we can write our access control list depending on what we need to do there. Okay. Write it in a text editor before you ever put it in, because when you start making changes, it's easier to most times just blow out the ACL, say no ACL, whatever, and then replace it. Document it using the remark command inside so you know what it's doing in case you forget. And then this is super important. As soon as you apply an ACL to an interface, it takes effect. So make sure you are testing it in development, because you can lock yourself out. And you apply an ACL, next thing you know, you can't get in at all. Now there was a day way back in beginning of creation where we went over standard and extended ACLs. We went over MAC ACLs. We went over IP and IPX ACLs. Now we basically are stuck with two types that we use: standard and extended. Standard ACLs are blocked by source address only. So it's only source address, which means you have to put them as close to the destination as possible. Extended, you can actually base on source and destination address and source and destination protocol and ports. So I kind of call the standard ACLs a shotgun approach. You just kind of get in the ballpark. And extended ACLs are like a rifle. You're dead on. You pick exactly what you want to permit or deny. They both have their uses. Typically, though, for more detailed work, we're going to be using extended ACLs. Standard ACLs are 1 to 99, usually the number 1 to 99. Extended are 100 to 199. That's their typical number that is used. You also can use 1300 to 1999 for standards, or you can do 2000 2699 for extended if for some reason 100 ACLs are not enough for your environment. You can also use what are called named ACLs. We use a lot of those, especially as we move up into CCNP level. So instead of using a number, we put IP access list, either extended or just a normal ACL. So IP access list and give it a name. The extended allows you to use the named ones, and you can get more detailed there. The important thing is this: when you name an access list, when you go to put it on an interface, the case must match exactly. So it's very important for you to know this too. I'm gonna put this in here. ACL creation. 1, create the ACL. So first thing you gotta do is create the access control list. And then you must apply it to an interface. The ACL will do nothing whatsoever until you apply it to an interface. You can have 400 ACLs on your router, and if they're not applied to an interface, nothing will take place at all. So you create it, then you apply it as inbound or outbound. Okay. So standard ACLs are placed as close to the destination as possible, and extended are placed as close to the source as possible. Now they will still break their rules sometimes, because for instance, if it was an ACL dealing with the 11 network, I would normally put that as an inbound on gig 001. Sometimes in the curriculum, they show it as an outbound on S010 for some reason. I don't understand that. Same thing here. If you're doing as close to the destination as possible, and it was one regarding this server down here, it should really be an outbound on gig 001. However, there's also some things that you think about in terms of you try to block traffic from going through the router and being using the router's CPU or being switched. And I know it's called switching, but it is actually switching inside the router between the ingress and egress interface. But when we can avoid it actually going through the router when it's going to be dropped anyway, we do that. So even though the rule is as close to the destination as possible, sometimes we break that rule to make things more efficient. So here's an example. Block all traffic from the 10.0.0 network to the 192.168.30.0 network. Okay, so that's here. If you were to put that on this incoming S010, you would also block the ability of the 10 network to get to the 31 network. But in this case, they put it as an outbound on gig 000. Now let's imagine that you also did not want this to be able to get access to the 31 network. I would then have put it on the S010. So it's an art. ACLs are an art, and you really have to think about that. Now here's one that says block FTP and telnet traffic from 11.0 network to 30.0 network. Well, since you know the source and destination, you can put it as an inbound in gig 001. Okay. If you put it as an outbound on S010, you'd also have to allow this 10 traffic. Otherwise, you would end up with the implicit denial blocking that traffic. So you have to be careful where you put these. Questions about access control lists. Questions about these basic rules for ACLs. All right. Let's look configuring the standard ACL. Create the ACL, place it on interface. So we're using a numbered ACL. We do access list, some number between 1 and 99 typically, permit or deny, and then source IP, and then source wildcard mask. Stop my video, maybe it won't show there. Doesn't matter. All right, so there's our remark if we want to use that. You can also use a named IP access list standard. That makes it a standard ACL, and then give it a name. Just remember, if you apply it to the interface, you would have to use all caps, no dash access, in order for it to be applied in or out. Then you apply it. Access list, IP access group, either the number or the name, and that name must match in case exactly. Otherwise, it will not apply. By the way, there's been several changes throughout the years when you applied an access control list that didn't exist on a router. The most recent iOS versions, I believe, block all traffic if there's no ACL there. We'll have to test that. It may be right, or it may actually be that it doesn't. It just passes it through because there's nothing there. I had to do some research on that because I can't remember. I don't think it says here either. Here's a named example: permit access, permit host 1010, and then you have to apply that as an outbound. And notice it has to match in case. That is a very big thing. The other thing here, you can do a show access list and it will show your access list, but it will not show you whether or not it's applied to an interface. So if you want to see where it's applied to, you actually have to go into either the interface itself or into the configuration to see it. But if you do a show IP int, include access list, it will show you what incoming and outbound access lists are applied on an interface. I cannot tell you the number of times I've seen people create ACLs and forget to apply them. So don't forget that. How do you modify ACLs? Well, one is using a text editor, you just remove it completely and put in a new version of it. Or you can use what are called sequence numbers. Typically, when you put in an access control list, sequence numbers, if you're using a standard named access list, you will get sequence numbers that are 10, 20, 30, 40. And if you want to put an item in between these two, you just add it with an additional number. So you could do no 10 and remove the 10 and then put a new one back in. Okay. Or you could, if you wanted an item between the 10 and 20, you could actually put 11. So you could go into the standard ACL and put 11 and put another entry in. And that would actually place it as item number 11. So by default, when you create a named ACL, okay, those sequence numbers are assigned and those sequence numbers are 10 to 20. So there's basically 9 extra positions in there. You can add different items. You can also change individual list items by doing this, by going no 10, removing 10, and then putting in another item. Okay, because notice here the mistake was we put 19 instead of 192. So you go back into access list 1 standard, and this is a very confusing thing because it looks like you're using numbers, but this is actually a named ACL named 1. Okay, because it's using the named nomenclature, but it just used the 1 as the name. But then we removed 10 because it was a mistake, and we put in the correct answer, or correct entry, access control entry. And then boom, it's changed. Okay. All right, let's see here. This is one of the most common uses for an ACL, and that is a thing called the access class command. So we create a standard access control list that says what IP addresses are allowed to go into your router via, or your switch via B2I lines. So you set a permit statement, and then you apply it to the B2I lines with an access class command. So access class, the number or name, in or out. Now, it's always going to be in for the B2I line. It won't be out. But here's an example. We're creating an access list called admin host that only permits the host 1010, denies everybody else. Now, that deny any wasn't needed, but it was put in there so that people would know and would understand that the deny was there. And then you put it as an in on the B2I line. Now, only this one host could telnet into this router. If you set up SSH, it works exactly the same. You would just put transport input SSH, access class admin host in, and only that one host. Don't suggest a single host being able to get in. I suggest allowing a management network. But this is how we control, using access control lists, access to our B2I lines. Questions? That's going to show up on the hands-on final. Just going to throw that at you. I know it is, no doubt. Now, extended ACLs, we're going to do our list by both source and destination IP addresses, source and destination protocols, and source and destination ports. So you'll see there's a lot more information here needed. So access list number, permit deny, protocol, source IP, source wildcard, destination IP, destination wildcard, port. So here we have all the different things, the port numbers. It can be, you can actually use names or port numbers. That's why it's important to know that 20 and 21 are FTP, 80 is web service, DNS is 53, TCP and UDP. Okay. The log command will log it into syslog if you happen to want to log the matches to an ACL. But here's an example, and then you just apply it with the access group command, just like we did before. But this one is more detailed. So we're doing access list permit, and here's all the protocols that can be allowed. So if you want to permit everything, you can do IP, or if you just want to permit a particular application that uses TCP, you can do just TCP or just UDP, or you can even get more granular if you want to get into even more granular. And then here is an example of permit TCP. So anything using the protocol TCP from any source, any destination equal, and then here's all the different items that show up when you do equal. So it's showing you DNS, FTP, web services, all of those. So here's an example: access list permit TCP from any source to any destination web traffic. So this will permit all web traffic. This is the exact same thing. It's just using 80 instead of www. Here's one. What does this permit?
Anything. It goes to telnet, doesn't it?
SSH. 22 is SSH. So this says permit anybody, any source to any destination equal SSH. This is any equal HTTPS right here. Then applying a numbered ACL, there it is. Access list, permit it. This permits anybody with web traffic, anybody with secure web traffic, and this is access group N, so you apply it as close to the source as possible, which is N on gig 000, which is for this. Now, with established is a keyword that's used to traffic that's either inside or outside. So if traffic originates on the inside of a network and goes out with a SYN, SYNAC, and ACK, you actually can create a simple firewall using what's called the established keyword. You have to actually have another firewall or another ACL on the inbound from the internet or the outbound with the established keyword. So basically this says access list 120, permit anybody established, group out. So that's 120 out, that lets it go out. And then 110, it automatically will create a 110 list that will allow only the traffic starting inside going out to come back in. So you create a 110 and using the established, and boom, it will actually allow anybody equal www, but it's only going to allow those that are established. So that's 120 out saying established, and this is inbound. It can make a very, very simple firewall. It's not something I would suggest you actually use as your main firewall, though. Okay. Folks, I'm going to run through this pretty quickly, but here's an example of a named ACL. It's called surfing. And they just give it a name permitting HTTP and HTTPS traffic. Same thing we saw before. Here's one called browsing. And then they apply it in and out. Editing these, you can do it using the sequence numbers just like before. So if you want to get rid of a particular entry and then replace it, you can do that using the sequence numbers. And then they've got some examples here. I'm going to let you read through these examples and bring any questions you may have to me. We have a good number of labs on ACL, so this is one of the most important things in ENSA. So I'm going to ask that you go and do those labs. They're not due for like 2 weeks or a week or so, but please go ahead and do those. And then next week in our class meeting, if you have any questions, we'll go over those. All right. By the way, we're going to use access control lists to determine what should be natted. It's called a NAT ACL. So it's important that you learn ACLs because they're used for everything. Any questions? No questions? I'm going to stop.